day, everyone. A big welcome to Wanies Academy. I'm here to teach chemistry, and the topic we'll be considering today is metallic bonding. The set aim for this class is to explain what metallic bonding is, and the objectives for this class are as follows. At the end of the class, the student should be able to 1. Define metallic bonding, 2. Explain how metallic bonding is formed. Then 3. Give examples of substances that have metallic bonding or exhibit metallic bonding. Then 4. Give properties attributed to metallic bonding. I commence my class in earnest. Now, metallic bonding is a type of bonding found in metals, right? From the name, metallic, right? Now, usually in this bonding, valence electrons are known to be shared. Remember, valence electrons are the outermost electrons. So valence electrons are shared among the lattice of positively charged metallic ions, giving rise to a sea of electrons in the metals. Now, it's a known fact that most metals will usually have 1 or 2 valence or outermost electrons. It's a known fact. Metals usually will have 1 or 2 valence electrons, which are loosely or weakly held to the atoms of these metals. Now, these valence electrons would usually have the ability to move around within the entirety of the metallic structure. And these same electrons are known to be shared among all the atoms of the metal. Now, simply put, we can describe the structure of metal by saying that metals are usually made up of positively charged metallic ions embedded in a sea of mobile or delocalized electrons, right? Now, these delocalized electrons, when compared to the typical valence electrons associated with ionic and covalent bonds, where the valence electrons are known to be shared or transferred between the specific atoms involved in such bonding, the delocalized or mobile electrons associated with these metals are known to have the ability to move throughout the entire metallic structure. So that means these mobile or delocalized electrons are correctly described as a sea of electrons, right? So now, usually, this sea of electrons are known to show attraction for the positively charged metallic ions in the metal, giving rise to strong electrostatic force of attraction that we simply refer to as metallic bond. And this metallic bonding in metals is responsible for typical metallic properties that metals are known to exhibit or show, right? Now, some of these typical metallic properties that metals are known to show include very high melting point and boiling point. So it's a known fact that metals usually have a very high melting point and boiling point. Then, secondly, it's also a known fact that metals have what we call the ability to undergo what we call malleability. So metals can be hammered into sheets. So one of the properties of metal is malleability. They are malleable in nature. You can hammer them into sheet. For example, corrugated iron roofing sheets. Then we also have what we call ductility. So metals are ductile in nature, meaning that they can be drawn into wire, since metals are known to be good electrical and thermal conductors. Then also, metals give up typical sounds, meaning that metals are sonorous. So when you hit metal, they give off a typical sound. So that's another property of metal. So all these associated metallic properties arise as a result of metallic bond, right? All right, so with that, we draw the curtain for today's class. Thank you very much for watching. Please remember to share this with family and friends. And remember to click on the subscribe button so as to come across more interesting and highly educative video. Thank you.